Okay, so it seems like we are live. So hello everybody. This is a weekly. It seems like we are live. There is a duplication. Is it from you, Marcel?
Yeah, sorry.
Yeah. So hello everybody. This is a weekly call of the Rainbow Bridge team. This call we are discussing what is happening there in the project. So let's start as usual. I'm going to share my screen. Keeping my fingers crossed that everything will be okay this time. Yeah. So are you able to see it?
Yes.
Cool. Hopefully it will stay as is. So I think that the general narrative is quite obvious to everyone who is following these updates. We are in the final stage of launching the Rainbow Bridge on the mainnet. We are doing right now the final checks of the Rainbow Bridge. We have updated the code base, so we are now testing it on the testnet whether everything's okay. Still catching some bugs. I need to fix this, but in general, we are targeting the release. We would like to make the release as soon as possible. It was scheduled for the next Monday, and hopefully we'll be able to do this. Though still some things are there that needs to be done. So let's go with the weekly update. So on my side, pretty busy week. Was trying. Well, I was doing lots of the code review and lots of the management around the bridge release. Lots of internal and external communications. So yeah, I was spending all of my time for this. Marcella?
Yes, I spent quite some time this week to merge the PR and the connector that implements the new standard for our fungible token, NEP 141, which is already implemented. In the last few days, I've been working a lot in the deployment of the bridge, all the infrastructure required, and all that is necessary. Like we made today we did a first attempt to deploy in the bridge. It was uh, a partial attempt to deploy the bridge, check that everything was good manually. We see some problems with the connector itself, no, not with the bridge, that we're trying to figure it out.
Cool. Eugen?
I was reviewing various parts of the bridge and token connector, and well, so was working with Marcelo to fix everything.
Yeah. Okay, Kirill? We cannot hear you, unfortunately.
There is not updating.
Yeah, the image.
Can you hear me right now?
Chinese. We
Yeah.
can hear you correctly.
Yeah, let's wait a bit with the image. Perhaps it will get solved by itself. So Kirill?
Can you hear me now? Okay.
Yep.
Okay, so this week I spent some time reviewing different PRs. Also, I worked on debugging and fixing simulation tests on the Rainbow Token connector, helping a little bit Marcelo with it. I also think this week with Evgeny Ukhanov on the ETH connector, and we discussed possible no STD options and solutions to proceed over this. As far as I know, Evgeny implemented this side already on his side. And I also working on debugging both sides of the ETH connector, troubleshooting it, and fixing and test and improving some scripts for it.
Okay. Can you please repeat the last time? The last thing, the last point.
Yeah, I told about that I worked on debugging both sides of the ETH connector, troubleshooting it and fixing tests and appropriate scripts for it.
Okay, cool. Pierre, what's on your side?
Yeah, busy week also on my side. So working on the new transaction signing flow implementation for NEP 141. And also on the new recovery feature that we discussed, so that users can always have a backup option to finalize their transfer should something wrong happen. So those were the two main issues, and recently investigating how we are going to use the two-factor authentication feature of the wallet to make this compatible.
Okay, cool. Hi, Ilya. Cool, great.
Hey.
So what do we need to discuss on this call besides this update? By the way, have the screen sharing resumed?
No. I think once it freezes, it doesn't resume.
Okay, got it. Then I just stopped it. So what about points for discussion? Since Ilya is with us, should we discuss the gas limiting problem with the connector right now?
Well, we need to figure it out first. What's the issue in first place? That if it might be possible that the function itself takes more than 300 teragas, in which case we need to split it, or there is something else going on. I guess.
So from what I see is just one of the callbacks doesn't have enough gas.
One of the callbacks don't have enough gas.
Yeah.
We're 50 teragas to each callback, which is quite a lot. I mean, you can increase it, of course.
Well, it's not always the right thing to put more gas, actually.
Yeah.
If you put more gas and then it wants to, well, anyway, let me check. But
I was thinking before that maybe call it with the wrong parameters, that maybe it's trying to deserialize something huge or something like that.
So if it used full gas, the gas used would be more than like 200 at least. So it's not using all the gas. Like because transaction is only used 44 teragas, and you can see that gas used is in one of the receipts, and then it actually gets called back, and then the callback, you see computation 0 was not successful. So you actually have still gas in the original transaction to execute callback of a promise that failed, to say that callback computation was not successful. So it's something like it calls, like when it calls one of the subsequent promises,
Yeah, but I see that transaction takes like 45 teragas successful transaction time, but I'm passing 50 teragas for each callback right now. Maybe for this particular state it takes more. It's possible.
Well, this is 44 across multiple calls, right?
Yeah,
so,
exactly.
Yeah, I think it's something a little bit more than just like, I'm just telling you, last time when people tried to debug this and just put more teragas, it just that doesn't work. You kind of need to understand what's going on first.
Yeah, I see.
Ilya, what is the typical problem with these type of issues? What's wrong with it?
Usually two things that can happen. One is you pass, for example, 50 teragas to a call, and that call needs to make its own call, and you attach 50 teragas there, and that fails because you only had 50 teragas, and attaching 50 teragas to subsequent calls doesn't work.
Oh, one question, because I think maybe I did something wrong. I create this promise in this way that the promise call another promise, and for the first promise, I attach 50 teragas, and then for the next one, I attach 100 teragas. Should I attach 150 to the first so that it can?
No, this is right.
Okay,
this looks right. Yeah, it's more if that call itself calls another call.
Yeah.
Like is the prover itself uses I think that's pretty much correct. Does prover uses its own async stuff?
Prover calls the bridge.
Yeah, so I think that's the problem. You call verify log entry, and then inside verify log entry, if it calls the bridge again and you attach 50 teragas there, then it just doesn't have 50 teragas to attach. Where's the connector?
Can you share your screen so we can?
Yeah, 1 sec. I'm just opening the rainbow. Yeah, here. Oh, you need to grant me this permission.
Give me a second. Yeah, try now.
Okay, so we have in here in Token Factory, we have verify log entry. Where is that contract?
This is not in that repository. It's in the Rainbow Bridge repository.
Yeah, right. This prover.
Yeah, we're passing 10 teragas to the client. Log hash save. It requires 10 teragas, and then we're passing the rest to block hash.
Okay, so we're passing 10 teragas here, and then we're passing half of on block hash.
25 teragas.
And this half is this half of 50 or half of the rest of this?
It should be half of 50.
Yeah.
Okay, so here's 25. Okay.
Yeah, so 10 plus 25 is just 35. And the hash assert itself. Okay, this looks. I mean, so one important piece, like if we look at the transaction, for example. A transaction, right? I mean, the only problem is like these are not in any particular order, but actually we can look at this information in a more understandable way. But you see, there's a bunch of receipts going on. So like you called deposit called something, that called, and so I mean, this is where logs are useful, at least like to know which one is going where.
Do we have some tool to display a graph of what called what? We here on the C result, but we want at least to see what were the receipt itself, what were the actions, what were the contract that was called.
Yeah, that's a good question. I mean, Explorer should be that tool, but it's not right now. Let me see what we can do from command line. 1 sec. Okay, from command line, you guys cannot see this, but actually, let me go full screen, I guess. All right, so here's output from command line if you just ask for this transaction. So RSVC testnet method tx params the hash. So it gives you like full thing. So transaction, you have the transaction action, which and the transaction outcome. So this is the first receipt that goes to the deposit. So this is receipt outcome. This has created 3 receipts.
And tokens burned here is this. What is this? Is it,
This
is it
is
the
just
gas?
for fees.
Okay. it's
Well, yeah, but and it's not
recalculated.
There's here gas burned, so you can see like.
Yeah. Okay. So the first call is not.
Yeah. So
20
first call
teragas.
burned 20 teragas. Have a good eyes on dividing things. Huh? So the second call. So here's we called 5VK. So this is. So it doesn't actually say, you see here, what it called, but like we
this
know
is
it
prover.
called the
Yeah, we
prover, yeah.
know that it's called prover. Yeah.
And so you see this status has gas exceeded for whatever reason. And it burned 19. So, and then, so it's still called back into this. Oh, yeah, so here, like the prover gas exceeded.
Okay. So we are passing some kind of wrong information to the prover, or the prover is passing it.
Our prover is trying to, attach too much gas. And then, so callback, it says computation, callback computation failed. So just let's double check. So finish deposit, assert. Yes, it's still, wait. How do we check?
Because finish deposit is done in then close. Yeah. So after this, you go down here, a little bit upper. Yeah. So here, yeah.
No,
so it's done after this.
But like this is called after this, but how do you know it's successful or not? Oh, this callback, this generates like false if the.
Yeah.
Yeah, exactly.
Yeah.
But it doesn't. Otherwise, it would say. Like it says callback computation 0 was not successful.
Yeah. So I believe this is assert
this part.
on 185. Okay. Or
no, it's not. It's not. Otherwise,
it's here.
Yeah. Failed. Yeah, it's here. Okay. It's just like the callback itself was. All right. So yeah. So it's definitely like when calling this, that function ran out of gas. So you can try to increase this for sure. To try. I mean, ideally, we would understand why it's happening.
Yeah.
So we have verify log entry. Because so it used 19. Okay, so it used 19, and we tend to attach 10, and we tend to attach 25. So yeah, it's 54 total. That's why it runs out of gas. Yeah. So do you know how long actually how much unblock hash really needs? Does it really need half of the gas for like one check?
Absolutely not.
Yeah, I mean that's why like as soon as you start like if you have like this prepaid gas divided by stuff and you increase like 50 to 60, it also increases, and sometimes it doesn't really help. That's what I was saying. Like just increasing is not. Always the right answer.
I think passing some fraction like half of prepaid gas is an anti-pattern. We shouldn't do it.
Yeah. I would try to avoid it unless you like know exactly what's going on, because like you kind of at the mercy of a caller, and then you don't really know how to like deal with what's happening. So yeah, I would switch here to like whatever, same 10 or even less, because that function seemed pretty small.
Yeah, but now, okay, yeah. So now we are attaching 25, but maybe it consumes less.
Yeah,
it can consume way less.
But the rest of the thing is, it's consuming too. But
so the other side is like make sure that. Because this means like the real proofs are way larger now than before, right? Like something happened. Why this is started using more gas than before?
The proofs are absolutely the same, so nothing have changed there.
Oh, I think before we were attaching more gas, and now we have a fixed amount, and that's why.
Yeah.
I see.
Yeah.
Okay.
So I'm just
Yeah,
looking.
And so the other piece I wanted to mention is like in 2FA, like the 2FA is, it's always needs to like consume less gas than like 300, right? Because it's already inside another call. It's like a callback already. So it's important to, yeah, if it's possible to call it from, if it needs to be callable from 2FA, then it needs to consume less than 300. Like, and you need to make sure you're attaching less than 300 when you're calling 2FA.
Yeah. So in December, the code was working, and on block hash, we were sending to on block hash 10 teragas.
Mhm.
And we were sending to block hash save a third of the prepared gas.
Yeah, so I would switch on block hash. I think on block hash can use even like it's not writing to storage. It's not doing this one computation. It's probably enough to send like, I don't know, 4 teragas even or even less. Whatever, 5. I mean, you can call like after deploying, you can call this like view how much each receipt used, how much gas each receipt used, and kind of adjust if there's no.
Yeah, we definitely need some kind of tool that allows us to estimate this more reliably.
There's a tool that's really hard to use. There's a profiler that if you provided state, code, and a function call, it will tell you exactly how much gas it's using, which functions it's called, and everything. Like there's a profiler.
And is it deterministic? Like it will behave exactly as interested? Okay.
Yeah, it's pretty much exactly what our runtime would run. Like it's literally a piece of our runtime runs. But yeah, it's like you will need to dump the state pretty much of the contract to really be able to.
Okay. Anyway, if you can share it later, I'll appreciate it.
I'll send it.
Yeah. So actually, I'm looking again back to the verify log entry. So that code was not changing. Block hash save, we were sending 10 teragas there, and on block hash, we were sending half of the prepaid gas. But probably we were sending more to the verify log entry than 50 teragas. So maybe on block hash here is consuming more. Well, maybe not this function, but we were sending more, and we were leaving for all of the rest of the computations. A little bit more, which is the computation itself, the most intense, I believe. This is verify try proof, and this is a call inside of the verify log entry of this function, and it's not a promise. So yeah, it seems like but in the other place. In the other thing, in the other piece of code, when we are calling on block hash, we are passing on the 10 teragas to it. So maybe we can change that line in the prover. In verify log entry, put instead of prepared gas divided by 2, we can pass there only 10 teragas.
We should, as yesterday again, we should just drop all fractions of prepared gas. And just fix a number.
Yeah, I'm just a little bit worried about the amount of time when we need to that we need to spend for figuring out what is happening. Okay, so it seems like, so what's the plan here, Marcela? What do you want to do?
Updating the gas is straightforward. We need to find good approximations, but I think it's I can use that command to inspect receipts, tx status, inspect receipts, and check the gas and use it. And we can deploy with some numbers we can estimate right now. If we got them wrong, we can upgrade later.
I propose to go the most fast way. So let's not go too deep into this because like the state of the mainnet is going to be different. The state of the Ethereum mainnet is going to be different. So the proofs are going to be different, you know. And this is not something that we are testing right now. So I would rather go with some numbers. So we could just try and somewhere to increase, somewhere to decrease, depending on what we have, and that's it. And then maybe so we just need to make it work, and then we would we can go a little bit in details with the proofs that are generated on the mainnet, so we can adjust this thing. What do you think?
Yes, sounds good as for now, like to unblock us right now.
Yeah. Because I also want to, to deliver something to Pierre to be able to work with and check that the front end is working. Well, to do minor things there. Okay. Yeah. So what else? Do we want to discuss something more? Anything besides this gas limiting issue? Pierre, on your side, can you comment on the 2FA and this pull request that is necessary for to be done in the wallet?
Yeah, so the 2FA is working on one side. So on the withdrawal back to Ethereum, it is working correctly after fixing the gas price that we're passing to the transaction, because the front end was going with 300 teragas maximum right away. So after fixing this one, it was working. However, on the other side, from Ethereum to Near, in proving of the deposit, it seems that there are some issues with setting the gas price. It's probably something related to what we just discussed, where it's always gas exceeded to verify that deposit proof.
But you're using the old connect and the old bridge, isn't it?
Yeah, so that's using the old bridge, and when I'm calling without the 2FA, it's using 65 teragas. But then switching to 2FA, the behavior is kind of surprising, and so I need to keep digging into this and probably have a look at the 2FA code itself to really understand what's going on.
Mm-hmm. So maybe we need to adjust some calls there, yeah? Or
yeah, like shares transaction that you're looking at?
The transaction, hang on, I don't know if I have this here. Yep. Okay, chat. It's in the Zoom chat.
Yeah.
Yep.
So there are two receipts. One is gas exceeded, and the other is the panic and callback.
Yeah, I mean it's the same place. Okay, let's see.
Do you want to share once again the console?
Sure. Well, so first, I mean, because it's a multi-sig, right? It's 2FA, so you want to look up this request itself first. So add request and confirm. And so you can see the gas here attached is 226 teragas.
Quite a lot.
And then, yeah, you're attaching here 250. So Yeah, I think. I mean,
So
it's the same place, so it fails due to
this
like also
250 is defined by the wallet.
yes.
Okay,
Yeah,
so that could
so
definitely be bumped to 300, right?
it can be, but again, adding more gas is not the right answer. Understanding the error is.
Yeah.
So,
No, but
so
in general,
what-
isn't it like a limitation to what a cold contract from the 2FA would be able to do?
Well, so 300 is a total limit, like on a single transaction. So the question is like, do you need whole 226 teragas for the whole call?
No. So if
Yeah, so reducing this is a first start, but this is not the issue. I mean, it's not failing because
yeah, reducing this to somewhere, I think the minimum was 65 without the 2FA. So reducing it to around 80 also gave similar similar results.
Mm-hmm. Yeah, but I think it's the same issue that we just looked at because we can check here.
Yeah, actually, that piece of code didn't change after the introducing NEP 141, so very likely it's the
Yeah,
same.
so it uses, you see, it uses 19
The same 19
teragas here.
teragas.
Yeah. So did this change from before or?
No, the code of the
No, no.
prover was not changed.
What changed from before is that now we're passing strictly 50 teragas,
50.
and before
I see, yeah.
we're passing some fraction.
Okay. Well, yeah. So that's the difference. Yeah, 50 seems like not enough for using a fraction, for using half to go
exactly.
to callback. Yeah.
Yeah, exactly.
So yeah, so this looks like the same issue. I'm just like the other 2FA issues that like when you do try to attach too much gas in this call, because then the like first call doesn't have enough gas to attach it to this call, but this is not in this case.
Okay, so it seems like the solution to both of the problems is to change the prover.
Yeah.
To
fix that. Yeah.
So decrease on the on-block hash from half of the prepaid gas to 10 teragas, and then we will have 30 for the new version. If we're talking about the new version, we will have only 30 for the verify log entry with the actual verified try proof method. That most probably is taking lots of gas. Okay, good. So it's good to know that these are not two distinct problems, but rather they are the same ones. Cool. What else? Okay, probably nothing. So let's then keep this call short. Let's focus now on fixing this gas issue, and once this fixed, then we would be able, to test the bridge. One thing that we also need to do is to test the upgradability of the bridge. So Marcel, once you're the good thing about the provers, well, all of the parts of the bridge on the near side is that you can redeploy it in place. So you don't need to redeploy anything else. So if something helps us. Yeah. So when you will do it, you just pin me, and we will be able to continue the tests with the fungible tokens, and hopefully everything will work. And then once we are going to be done with it, we will start with the upgradability. Okay. Cool. So stay tuned, and see you soon. Goodbye, everybody.
Bye.
Bye, everyone.